All right, today in geometry, we are starting chapter 4. We're looking at section 4.1, which is about applying triangle sum properties. So let's first talk about what is a triangle. So a triangle is a polygon with 3 sides. A triangle with vertices A, B, and C is called triangle ABC. Or we can use notation. Instead of writing out the word triangle, we can draw a triangle, say triangle ABC. So we're going to review how we classify triangles by sides. So we have first a scalene triangle. This type of triangle has no congruent sides. So if we had marks, all the sides would have different marks. An isosceles triangle is a triangle with at least 2 congruent sides. So this one could look like this one and this one the same, and the 2 that are the same are called legs, and then the other one is called the base. An equilateral triangle is a triangle that has 3 congruent sides, so all 3 sides are the same, because remember equilateral means equal sides, so they would all have the same tick marks. All right, so then let's look at classifying triangles by angles. We have an acute triangle. An acute triangle will have 3 acute angles, and remember acute means less than 90 degrees. So this is less than 90 degrees. A right triangle will have 1 right angle. Remember, right angle means 90 degrees. It will be marked with that little square. An obtuse triangle has 1 obtuse angle, which means that your angle is greater than 90 degrees. And then equiangular, remember equal means equal and angular means angles. So it has 3 congruent angles, so they would all 3 have the same marks. Okay. All right, let's classify the triangle by the sides and the angles. So number 1, I see that all 3 of my sides are different lengths. I have a 5, a 2.9, and a 5.8. So that means this is scalene by the sides, so it is a scalene. Now we're going to classify it by the angles. I have a 30 and a 60. This is a 90, so then I have a right triangle. So I have a scalene right triangle. And I know that this is 90 because remember that all 3 have to add up to equal 180. I have 60 plus 30 is 90. 180 minus 90 gives me 90. All right, number 2, let's look at it. I have all 3 of my sides are labeled 17 and all 3 of my angles are labeled 60 degrees. So this is an equilateral because all the sides are the same. All the angles are the same, so equiangular triangle. And number 3, I have the sides that are at 10, 10, and 18. I have 2 sides the same, which means I have an isosceles triangle. Now we're going to label by the angles. I have a 30 degree, a 30 degree, and a 120 degree. 120 is bigger than 90, so that's obtuse. So it is an isosceles obtuse triangle. Okay, so next one, it tells me a triangle has the given vertices. Graph the triangle and then classify by its sides and determine if it is a right triangle. So first plot the points. So A is at 2, 3, so over 2 up 3. There's my A. B is at 6, 3, so 6, 3. There's B. C, 2, 7. So that's right there off my graph a little bit, just by 1. So connect. Okay, so now I need to classify by its sides, so I need to know what are its sides. A to B, I can count those squares. I have 4. A to C, I can also count my squares. I have 4. I can either do the distance formula or the Pythagorean theorem to find BC. So if I do Pythagorean theorem, I've got BC squared equals 4 squared plus 4 squared. So BC squared equals 16 plus 16. So BC squared equals 32. I don't want BC squared, so take the square root of that. So then I get BC equals the square root of 32. But remember that I need to reduce that, so factor tree if I can. So 32, I know that's 8 and 4. 8 is 2 and 4. I could break down my 4s, but remember I don't have to because all I need is a pair, so I already have a pair of 4s. So BC is equal to 4 square roots of 2. So this is 4 square roots of 2. And so I automatically know that this is a right triangle because I did Pythagorean theorem. And since I had a horizontal line and a vertical line meet each other, that forms perpendicular lines, which is the right triangle. So it is by the sides. I have two sides that are the same. That's an isosceles. And then the angle was a right, so it's an isosceles right triangle. All right. Next thing, we're going to talk about some angles. When the sides of a polygon are extended, so here you see we've drawn this triangle in the center, but we extended all of those sides. Other angles are formed. The original angles are the interior angles. So, whoa. Let's see if I can get rid of that stray mark there. Okay. All right, so this is an interior angle, this is an interior angle, and this is an interior angle. So my purple are my interior angles. I'm going to switch colors. It tells me the angles that form the linear pairs with the interior angles are the exterior angles. Okay, so linear pair, so I've got this one, this one, this one, this one, this one, and this one. So my blue are my exterior angles. The markings that I did don't mean anything about them being congruent or anything. I did not mark my congruent angles. Okay. All right, next page. We have some theorems. The first one is theorem 4.1, the triangle sum theorem. It tells me the sum of the measures of the interior angles of a triangle is, we already know this, 180 degrees. So here I have this picture, triangle ABC. I could say that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Next, we have theorem 4.2, the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Remember, non-adjacent means does not touch. Okay, so here my exterior angle is angle 1. My non-adjacent angles are A and B. So I would say that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. And then we have the corollary to the triangle sum theorem. It says the acute angles of a right triangle are complementary. So then we have this picture of the triangle ABC. Angle B is my right angle. So then it tells me that measure of angle A plus the measure of angle C would have to equal 90 degrees. All right, so now let's work out some problems. Just says find X. This is a right triangle. It's actually marked as a right triangle on your notes. So I know that since I have a right triangle, that my other two angles have to add together to equal 90. So then I've got 35 plus X has to equal 90. Subtract 35 from both sides, so I get X equals 90 minus 35, which is 55 degrees. It's an actual angle, so I put the degree symbol. Number 2, I have an obtuse triangle, 125 degrees, 20 degrees, and X. I know all of these have to add up to equal 180. So X plus 20 plus 125 equals 180. There's our equation. Combine like terms, so 20 plus 25 gets me X plus 145 on this side equals 180. And now to find X, subtract 145 from 180 and we get 35. Again, X represents an angle, so 35 degrees. All right. One last page. And the measure of angle BAC and the measure of angle BCA. And again, on your notes, this is marked a right triangle. So I know that 3x plus 11 and 4x minus 5, so BAC and BCA, I know together they have to add up to equal 180, or sorry, 90. So I would say 3x plus 11 plus 4x minus 5 equals 90. Combine like terms, so 4x and 3x gets me 7x. 11 minus 5 gets me plus 6 equals 90. Subtract 6 from both sides, so I get 7x equals 84. Divide by 7, 84 divided by 7, x is equal to 12. So now I just need to plug that in. So here, the measure of angle BAC is equal to 3 times del of x, now 12 plus 11. So 3 times 12, that's 36 plus 11. So the measure of angle BAC is equal to 47 degrees. Now to find the measure of angle BCA, I can just do 90 minus 47, since I know the two of them together had to equal 90, or I could plug 12 in for that x, either way. So the measure of angle BCA is equal to 43 degrees. All right, some more, find x and y. Here I have an exterior angle, and then the two interior angles over here. And remember, we have that theorem that tells me that the exterior angle equals the two non-adjacent angles added together. So here I would say y equals 70 plus 88. So y is equal to, when I add 70 and 88, I get 158 degrees. Number 2, I have y as an exterior angle and 52. Remember that an interior and an exterior, okay, that sit side by side make up a linear pair. Remember from way back when, a linear pair means they add together equal 180. So our equation would say y plus 52 equals 180. So here to solve for y, we simply subtract 52 from 180 and we get y equals 128 degrees. Number 3, again, I have exterior angle and the two non-adjacent angles. So again, y is equal to 42 plus 20. So I get y equals 62 degrees. All right, find the measure of angle BCD and the measure of angle ABC. Again, I have an exterior angle out here, 5x minus 2, my two non-adjacent interiors. So 5x minus 2 equals 2x plus 76. I'm going to get all of my x's on the same side, so I'm going to subtract 2x over, so I get 3x minus 2 equals 76. Move my 2 over, I get 3x equals 78. And finally, divide by 3, so x is equal to 26. Now I can plug that in to find the measure of these. So if I plug it in angle B, 2 times 26 is 52 degrees. So the measure of angle, let's see, ABC is 52 degrees. The measure of angle BCD, several ways I could find it. I could just plug x in, 5 times 26 minus 2. So 5 times 26, that's 130, minus 2. So the measure of angle BCD is equal to 128 degrees. So those are my two answers. And I lied a while ago when I said last page. This is now our last page. Okay, so again, find the measure of angle ABD and the measure of angle BDC. Again, I have an exterior angle and the two non-adjacent interior angles. So I know my exterior, 3x, has to equal my two non-adjacent added together, 2x plus 30. Get all of my x's on the same side, so when I subtract 2x, I get x is equal to 30. So now I can just plug that in. So the measure of angle ABD is equal to 3 times 30, which is 90 degrees. So I have the measure of angle ABD equals 90 degrees. And if I just plug 30 in here, 2 times 30 equals 60 degrees. So then the measure of angle BDC is 60 degrees. One last problem. Find the measure of angle CAB and the measure of angle CBA. Again, on your notes, this is marked 90. So I know that those two together, A and B, have to add together to equal 90 since angle C is 90. So my equation 8x plus x equals 90. Combine like terms, so I get 9x equals 90. Divide by 9, x equals 10. So this is 10. If I plug it in up here, 8 times 10 is 80. So then I have the measure of angle CAB is 80 degrees. The measure of angle CBA is 10 degrees. All right, so that is section 4.1, applying our triangle sum properties. Simply a lot of this was review for us. Not too bad. Our homework tonight is 4.1 worksheet.